1 billion dark matter particles just passed through your skull in the last second. We have no idea what they are. And here's the thing. That's not a figure of speech. That's not a metaphor. That is, as best as we can calculate, a literal description of what just happened to you right now while you're watching this. And somehow, that might be the least strange part of this story. Because the deeper you go into what dark matter actually is, or might be, the more you realize that the universe is hiding something enormous. Not at the edge of space, not in some exotic corner of the cosmos, but here, everywhere, passing through your living room, your walls, your bones, without leaving a trace. So let's actually figure out what we know, what we don't, and why this mystery might be the most important unsolved problem in all of physics. Because the answer, if we ever find it, will rewrite the textbooks, every single one of them. We know something is out there because of what it does to things we can see. That's how this whole story starts. Not with a direct detection, not with a photograph, but with a rotation curve. In 1970, an astronomer named Vera Rubin was studying the Andromeda galaxy, our nearest large galactic neighbor, trying to map how fast different parts of it spin around the center. Basic physics, Newtonian gravity, predicts what should happen. The stuff at the center, where most of the visible mass is packed, should pull everything around it the way the sun pulls the planets. Close in, fast. Bar out, slow. Mercury screams around the sun. Neptune crawls. That's how gravity works. Except that's not what Rubin found. The outer edges of Andromeda were spinning just as fast as the inner regions, maybe faster, which is, from a physics standpoint, completely insane. It's like if Pluto orbited the sun at the same speed as Mercury. The math doesn't work unless there's something massive out there that we can't see. A halo of invisible material wrapped around the entire galaxy, providing the extra gravitational grip that keeps the outer stars from flying off into intergalactic space. Rubin didn't just find this in Andromeda. She found it in galaxy after galaxy, dozens, then hundreds. The pattern was undeniable. And this invisible stuff, this gravitational ghost, is what we now call dark matter. But here's where it gets strange. When physicists tried to figure out what dark matter actually is, they hit a wall. Because everything we know how to detect relies on one thing: interaction. Light is detectable because photons interact with the electrons in your retina. Radio waves interact with antennas. X-rays interact with film. Even neutrinos, those ghostly particles produced by the sun that pass through Earth like it isn't there, even they occasionally bump into something. And we can catch them in enormous underground tanks of water. Dark matter doesn't seem to do any of that. It doesn't emit light, doesn't absorb light, doesn't interact with the electromagnetic force at all. It barely seems to notice normal matter. The leading candidate for decades has been something called a WIMP, a weakly interacting massive particle. The name tells you almost everything. It has mass, we know that because of its gravitational effects, and it interacts weakly through the weak nuclear force, the same force responsible for certain kinds of radioactive decay. Massive particle, weak interaction, almost impossible to catch. But if WIMPs are real, the math says the galaxy is filled with them. Not sparsely, densely. Right here, at Earth's location in the Milky Way, there should be roughly 300 dark matter particles per cubic meter. Think about what that means. Every cubic meter of space around you, including the space inside you, is saturated with dark matter. It's not passing through the room. It's in the room. It's in you all the time. And because these particles are moving at hundreds of kilometers per second relative to us, that works out to about 1 billion dark matter particles passing through a human head-sized volume every single second, which is the number I opened with. And it's genuinely real, not a metaphor. So we have the detection problem. Physicists built detectors to try to catch WIMPs. The idea is simple in principle. If you fill a chamber with something heavy, like liquid xenon or germanium crystals, and you wait long enough, eventually a WIMP should hit an atomic nucleus hard enough to produce a tiny detectable recoil, like a bowling ball hitting a billiard ball. And to make sure you're not just seeing cosmic rays or radioactive noise, you go deep underground. The Large Underground Xenon Experiment, LUX, was built a mile underground in a former gold mine in South Dakota. The Xenon 1 trillion detector at Gran Sasso in Italy is buried under a mountain of solid rock. These are some of the most sensitive instruments ever built by human civilization, and they have found nothing. Not a single confirmed dark matter detection, which is either telling us that WIMPs don't exist or that they're even harder to catch than we thought. And this null result has started pushing physicists toward wilder ideas. What if dark matter isn't WIMPs at all? What if it's axions, hypothetical particles originally proposed to solve a completely different problem in quantum mechanics? So light, they make neutrinos look heavy. What if it's primordial black holes? Not the stellar collapse kind, but tiny black holes formed in the first fraction of a second after the Big Bang, before any stars existed? What if dark matter is a particle we've never imagined, from a sector of physics completely disconnected from anything in the standard model? The honest answer is, we don't know. And here's the thing that keeps physicists up at night. Dark matter isn't a small part of the universe. It isn't a footnote, the stuff that makes up everything you've ever seen. Every planet, star, galaxy, nebula, every atom in your body. That's only about 5% of what the universe is made of. Dark matter is roughly 27%. The remaining 68% is dark energy, which is a whole other nightmare. What we think of as the real universe is a thin layer of foam floating on an ocean we can't see, can't touch, and can't explain. And here's the reveal that makes everything stranger. We've actually mapped dark matter, not by seeing it, but by watching the way it bends light. Einstein's general relativity says that mass warps space-time, and warped space-time bends the path of light. So when light from a distant galaxy travels through a region of space filled with dark matter, that light gets lensed, distorted, stretched, sometimes split into multiple images. By analyzing these distortions across millions of galaxies, cosmologists have produced maps, actual maps, of where dark matter is concentrated throughout the observable universe. And what those maps show is almost architectural. Dark matter forms a cosmic web. Long filaments of invisible material stretch between galaxy clusters, with vast empty voids between them. Galaxies form along those filaments, like beads on a string. The visible universe is essentially a shadow cast by the dark universe. The stars and galaxies we see are just where the dark matter was dense enough to pull normal matter in and ignite nuclear fusion. Without dark matter structuring the cosmos this way, galaxies probably couldn't have formed at all. Which means, follow this chain, without dark matter, there's no Milky Way. Without the Milky Way, no solar system. Without a solar system, no Earth. Without Earth, no you. The invisible stuff you've never detected, that passes through you constantly without leaving a trace, is possibly the reason you exist to not detect it. That loop is real. So where does this leave us? We're living inside a solution to a problem we haven't solved yet. We know dark matter exists with about the same certainty we know the Earth exists. The gravitational evidence is overwhelming, but we have no idea what it is made of. We've never held a piece of it, never photographed it, never made it in a particle accelerator. We've only ever seen its shadow. And right now, as you watch this, the search is continuing. Next generation detectors are being built with even lower detection thresholds. The Vera Rubin Observatory, named, fittingly, for the woman who made this problem undeniable, is being constructed in Chile to map gravitational lensing across billions of galaxies. The LHC at CERN is searching for evidence of dark matter production in high-energy collisions, and theorists are exploring ideas that would have sounded absurd 15 years ago. One of those ideas is genuinely haunting. Some physicists have proposed that dark matter might not be a single type of particle, but a whole dark sector, a parallel set of particles and forces that interact with each other, form dark atoms, maybe even something like dark chemistry, but remain completely invisible to us because they have no electromagnetic interaction with our sector of the universe. A universe within the universe, invisible, co-located. Right here, we'd never know. The billion particles that passed through your skull in the last second might be part of a physics so alien we haven't even built the language to describe it yet. And the only reason we suspect any of this is because a woman named Vera Rubin pointed a telescope at a spiral galaxy and noticed the stars were moving wrong. So what do you wonder now? Think about the opening line again. A billion dark matter particles passed through your skull in the last second. We have no idea what they are. The second time you hear that, knowing what we know now, does it hit different? Because here's what we've actually established. Those particles are why the galaxy exists in the shape it's in. They're why Earth formed. They're possibly part of a physics we can't even see the edges of yet. And they are, right now, passing through you like you're not there. Like normal matter, the stuff you're made of is the ghost. Comment below. What's the implication that breaks your brain the most? Because mine is this. We call it dark matter like it's the strange one. But from its perspective, if it has one, we might be the exotic minority clinging to a thin film of electromagnetic reality inside something much, much larger.